Wedeter editorial, July 2026, 8-minute read. Watch video. Building a local AI workstation that grows with you. Lessons learned. When I first dipped my toes in a local AI, I was obsessed with finding the fastest, most expensive rig possible. I thought power was the only metric that mattered. I was wrong. After months of trial, error, and some expensive hardware mistakes, I realized that the goal of a local AI workstation is not to chase peak performance today, but to build a system that remains capable and flexible as the technology evolves. Cloud AI services are convenient, but they are subject to outages, censorship, and recurring costs. My goal was simple: to own a system that keeps working regardless of internet connectivity or corporate policy changes. Defining your AI requirements before you buy. The biggest mistake most people make when building an AI workstation is buying hardware first. They see a high benchmark score or a shiny GPU and assume it is the right choice. Instead, you need to answer a series of questions about your actual workflow. What do I actually use AI for? In my experience, my requirements shifted drastically once I started running models locally. I needed capabilities for writing books and long-form content, coding assistance and refactoring tools, local image generation that does not require an internet connection, video generation tasks, deep research and processing large documents, running long, multi-turn conversations, experimenting with autonomous AI agents. I had to distinguish between my nice-to-have features and my must-have requirements. For instance, while high-end video generation was tempting, my immediate need was a robust system for coding and writing. By defining these needs first, I was able to stop shopping for fastest and start shopping for most relevant. It saved me from buying unnecessary components that would have only added heat and noise to my desk without actually speeding up my workflow. The technical foundation: how local AI actually works. Understanding the hardware starts with understanding the constraints of local AI. If you do not grasp these fundamentals, you will almost certainly waste money. I spent a long time reading documentation and testing different models to understand how parameters, quantization, and memory actually interact. The most critical realization I had was that RAM matters far more than most beginners assume. Key concepts that shaped my purchasing decision included parameters. The size of the model determines its intelligence, but also its resource footprint. Quantization. This is the process of compressing models to run on consumer hardware with minimal loss in quality. VRAM versus RAM. While VRM, video RAM, is the gold standard for speed, system RAM is increasingly viable for running larger models if your CPU and memory architecture allow for it. Context window. This determines how much data the model can remember at one time. A larger window requires significantly more memory. Software ecosystem. Your hardware is only as good as the software stack running on it. Whether it is an LLM, a coding assistant, or an automation script, the operating system and the specific software you choose to run will dictate your real-world performance more than any specific clock speed. I learned that local AI is not just about raw compute. It is about memory management and bandwidth. If you cannot fit your model and its context into memory, it will not run, or it will be painfully slow. Software optimization has become the hidden hero of the local AI movement, enabling decent performance on hardware that would have been considered underpowered just a year ago. Comparing options and why I chose the Ryzen AI HX 370. I evaluated every major form factor available: old desktops, gaming laptops, MacBooks, purpose-built AI laptops, and mini PCs. Each had distinct pros and cons. A gaming laptop, for instance, offers great raw power, but often comes with terrible battery life and limited upgrade paths. A MacBook is excellent for power efficiency and unified memory, but can be prohibitively expensive to configure with sufficient RAM for the long term. I eventually settled on the Ryzen AI HX 370 with 64 gigabytes of RAM. My choice was not based on it being the fastest option, but because it offered the best balance of the factors that mattered to me. Price. It allowed me to get a high-performance CPU with integrated AI capabilities without the premium tax of some other platforms. Expandability. I needed a machine that I could modify. Connectivity. USB 4 support is a deal breaker for me, as it allows for future eGPU, external GPU, expansion. Linux support. Support. I wanted a system that played nicely with my development environment. Future-proofing. Between the socketed or upgradable RAM and the ability to add an eGPU later, I have a clear path to improve the system without replacing the entire laptop. Portability. It serves as a daily driver that I can take with me, unlike a desktop setup. This machine was not perfect, but it was the most pragmatic choice. It solves my problems today while leaving the door open for tomorrow. Planning for the future instead of buying everything today. My final piece of advice is to resist the urge to buy everything at once. I treated my workstation like a roadmap rather than a single purchase. I wanted to build a system that grows as my skills and requirements change. My stage-based approach helped me save money and avoid feature creep. Stage 1. The laptop itself. This is my core foundation. Stage 2. Upgrading the internal SSD. I started with a decent drive, but planned for a larger one as my datasets grew. Stage 3. Expanding to 128 gigabytes of RAM. This is my planned path for handling much larger context windows. Stage 4. Investing in an eGPU. This is for when my local image and video generation needs outpace my current integrated graphics. Stage 5. Transitioning to a full-size desktop GPU if the eGPU becomes a bottleneck. I intentionally did not buy a docking station, a fancy USB 4 SSD, or expensive external monitors at the start. I focused the budget on the machine itself. Most of the accessories people buy are temporary fixes for hardware that wasn't chosen well in the first place. By buying only what solves today's problem, I kept my costs down and maintained the flexibility to adapt to new technology. Key takeaways. Define your AI use cases coding, writing, or generation before looking at a single hardware spec. Memory, RAM/VRAM, is almost always more important than CPU or GPU speed for local AI. Think in terms of a roadmap rather than a final purchase. Buy for today, but build for the ability to upgrade. Software choices, like the OS and inference engines, can often compensate for hardware limitations if you choose the right tools. Avoid the trap of buying extras like expensive docks or accessories. Put that money toward the computer's core specifications instead. The goal was never to build the perfect computer. The goal was to build a system that could keep up with me. If you're just starting, do not be intimidated by the technical jargon. Start with your requirements, prioritize memory, and pick a platform that gives you room to grow. Related articles. Building a local AI workstation that grows with you. Local AI versus cloud AI. Best AI tools for beginners. Best local AI tools. How I use AI tools. Business tools. Websites worth bookmarking. YouTube. Wedeter. We determine what connects. Explore. Home AI and technology. Business and money. Books and publishing resources. Quick links. About privacy policy. Terms of use. Contact. Copyright 2026 Wedeter.com. We determine what connects.